Okay, let's take any map M between a domain and a codomain W. Well, over here, I have the range space, and over here I have the null space, and the null space goes to the zero vector. And all of the rest of these vectors go to R. Well, so it turns out that all the vectors over here, none of them can go to zero. So they all go to somewhere in the range space over here. But it turns out that if I just look at the vectors out here that go here, there's going to be some basis vectors, say V1 and V2, that are in here, and then there's going to be some basis vectors V3 and V4 out here. And this V4 and V3 are going to get mapped to vectors over here. And it turns out that the dimension of this space outside of the null space is going to be the same as the dimension of R. So this space out here has the same space as you can show that the dimension of range space is the dimension of all the vectors that are out. This isn't a vector space, but there's all of this, the vectors out here, with a linear combination of all these vectors out here is the same number as the vectors. Well, okay, I'm mangling this, but the upshot is that the dimension of N plus the dimension of R equals the dimension of V. Okay, so this is the nullity plus the rank equals dimension of domain. So let's say that, as an example, let's say that you had a map P from R3 to R2, and the rank was 1, right? Well, you know that the nullity of the map plus 1 has to equal 3, the dimension of the domain. Therefore, you know right away the nullity is 2. You can calculate the null. You can get if you always know the dimension of the domain, but you can, if you know the rank, you can get the nullity right away, and if you get the nullity, you can get the rank right away. Now, just as a warning, in the homework, you can't use this theorem to solve the problem. Like if I ask you for the rank and the nullity, you can't just find the nullity and say, okay, or the rank and say, okay, now we can use this theorem. I want you to go through the process, and I'll make that clear so that this is you can use this to check. Use this to check answers. And sometimes I'll ask you, like, I'll ask you if you don't have enough information, like if I give you in a regex problem, like on a concept check, I give you some of this information, like if I give you the nullity and the rank, what's the dimension of the domain? Like if the rank was 5 and the nullity was 2, what's the dimension of the domain? Well, it's going to be 7. Because you have this is like one equation, and if I give you 2 of the integers, you can get the third for free. Okay. We only have 4 minutes left, but so basically what we're going to do now is we'll go and do problems of because this is basically this whole, rank and nullity, there's that theorem there. This is basically, there's some filling out the consequences of this, but it's basically, this is the chapter. This is the end of the chapter. I think this is the last exercise. So this chapter, you have the ideas of linear map one-to-one onto. And then you have this map of vector spaces. You have sort of range space, null space, kernel, and nullity, and those are related to the one-to-one onto properties. Okay, so this is sort of all the theory. Now we have to go back and actually practice with it and stuff. So you can start on the homework problems. Hopefully that you can see, can you figure out how to start? There's examples with text and on regex. And let's see what the problems on regex might look like for this. So you have isomorphisms and you have linear maps here. And then you have properties of linear maps and bases. So here's the general map. What's the action? Like I've given you here a map. What's the action of this map on the standard basis? And then here's an action of the standard basis. What's the action, the general formula? We just did an example like that today. And here's range, space, and rank. Here's a map. Where's the range space of this map? And where's the range space of this map? So you can. This is just the definition, right? And then the right arm is a span of 3 vectors, in some simple way. Okay, and then the 3 vectors. The second vector is a multiple of the first. It is linearly dependent, therefore it can be removed, and you have this is this actual space, and then what's the rank of the map. This is just sort of trying to review concepts, and you notice for these ones, because there's a little bit of, you have lots of attempts, but then here's null space and nullity. So this is trying to review the definition, right? And then here's rank plus nullity. Okay, here's a map. What is the value of the sum, rank plus nullity? Now you could do it the hard way of trying to find the rank in the null space independently, or use that theorem we talked about. Okay, so that that is these exercises you can now probably do. And isomorphisms. Let's see. The images of vectors. These are old questions, yeah. And here's a map. What properties? Linear 1-to-1 is an isomorphism, recognizing isomorphisms. And then here is, the dimension theorem. Which ones of these are isomorphic? So I think you can do all the regex questions on the basis of what we've done so far with this stuff, and then you can do some of, but not all of the Lix problems. Like you can do this first one here. What's the range space? What you're going to do is you'll say, what's the set of all of these things? Find a basis for it. Find the number of elements, the dimension, that'll be the rank. What's the kernel? It's all of these polynomial things for which this maps to 0. So the kernel is going to be a space of polynomials, and the dimension of that space will be the nullity. And then here's 2 isomorphism question. Then this is what's the range space, the rank, the kernel, and the nullity of a map here. Same thing here. And this one, the later questions 6 and above all deal with matrices, which is stuff we haven't talked about yet. So you can so if you can work on and do the first half of the assignment so far. Okay, well, it's over time, so we can. Thanks for being patient with all this stuff, because it's a lot of stuff to absorb. Okay. So, any particular questions?
Can I ask a couple of fast housekeeping questions?
Excuse me?
There's just a couple of housekeeping questions.
Okay.
So I think that you mentioned before the break that